Audio and vision agents operate on discrete inputs, a single image, a bounded audio clip. But physical environments do not arrive in clean snapshots. They produce a continuous, chaotic stream of data. This diagram places Agent 21 at the conclusion of the multimodal perception tier, serving as the cognitive bridge to physical reality. But the physical world is hostile. Hardware sensors drop packets, calibration drifts, and data arrives asynchronously. Motion detectors fire instantly. CO2 monitors lag by 30 seconds. When an agent interacts with a digital API and fails, the system can simply retry the call. Physical actions have immediate consequences. Opening a water valve or shutting down a server room cooling unit cannot be reversed with a keystroke. Operating in this environment requires an architecture specifically engineered to digest chaotic telemetry without making catastrophic hardware errors. Look at this line chart mapping a sudden temperature spike to 150 degrees. A naive control system treats this reading as absolute truth, violently triggering a cooling response. But physical phenomena do not teleport. Rooms follow scientifically plausible curves. That spike was electrical interference, not a fire. The defining directive of Agent 21 is disciplined skepticism. It must never trust a single, isolated sensor reading. Instead, the system gathers disparate, noisy data streams and applies mathematical filtering to fuse them into a single, reliable representation of the environment, a calibrated belief state. The primary challenge of physical sensing is not data collection. It is determining what is mathematically defensible to believe before initiating a physical action. This visual demonstrates the digital twin concept. On the left is the raw, static-filled data. On the right is the digital twin, a stable, smoothed internal model that filters out hardware noise to represent the true state of the room. Relying on binary control logic for every minute fluctuation causes physical hardware to oscillate violently. This rapid switching, known as short cycling, destroys mechanical equipment. This chart shows the solution: proportional control. As the actual state approaches the target line, the agent gradually reduces the actuator's power output in direct proportion to the remaining error. It eases the throttle instead of slamming it. Now notice the purple region around the target line. This is the deadband. It provides a built-in hysteresis buffer where the system safely idles, ignoring minor environmental variations entirely. Together, the deadband and proportional control function as the AI's suspension system, protecting the hardware from the destructive impact of constant corrections. This flowchart maps the complete 6-stage operational loop of Agent 21, tracing raw data from the physical world through the agent's internal logic and back out to the actuators. In blocks 1 and 2, the system ingests heterogeneous sensor streams and applies a 5-minute temporal filter. This mathematical window actively discards transient spikes before they reach the reasoning layer. Stage 3 constructs the digital twin state. Here, the architecture separates the static, invariant constraints of a room, its configuration, from the dynamic, live readings defining its current state. In Stage 4, the agent reasons over this fused state. Rather than executing hard-coded logic, it matches the data against modular event patterns to detect anomalies. Stage 5 dictates the action. The agent executes proportional control and respects the deadband, safely determining the exact output required to drive the physical actuators. This continuous sense, model, plan, act loop ensures the agent always bases its physical commands on a stabilized, verified model of reality. Looking at the Python implementation, we see exactly how the agent structures its reality. These data classes enforce the strict separation between the static zone configuration and the dynamic, fused zone state. In the sense phase, the agent applies the temporal filter by querying a moving 5-minute cutoff window. Any reading older than 5 minutes is dropped, and variations within the window are smoothed through averaging. This is the reasoning block, defined by the event pattern class. Here, the continuous hum of sensor data is translated into discrete, actionable insights. By treating rules as data using lambda functions, engineers can inject complex, multivariant anomaly detection logic, like tracking unexpected occupancy outside of business hours, directly into production without altering the core compiler. Finally, the control manager executes the digital suspension system. This logic dictates how the agent translates a calculated error into a physical command. The code establishes a firm 1-degree deadband threshold to prevent short cycling. Outside of that buffer, it calculates the intensity by multiplying the absolute error by 20, applying exact proportional gain. These specific lines of Python form the operational boundary between intelligent digital reasoning and hardware failure. This abstract dashboard illustrates how this exact pattern scales. The logic governing a single room is identical to the logic governing massive industrial facilities. Enterprise deployments rely on this loop for complex environments, managing smart corporate campuses, executing data center thermal regulation, and tracking cold chain safety in research labs. There is a strict structural limitation. Agent 21 manages fixed environments. It orchestrates complex systems, but does not roam or possess localized physical dexterity. It is a facility manager, built exclusively to orchestrate and stabilize overlapping physical ecosystems reliably. With Agent 21, the multimodal perception tier is complete. Agents can process discrete pixels, parse audio prosody, and stabilize continuous physical realities. The foundational architectures, mathematical filtering models, and Python logic for these systems are detailed in Imran Ahmad's 30 Agents Every AI Engineer Must Build. You can explore the complete code repositories and operational blueprints for all 30 agents through Pact Publishing and at neuralsca. The foundation of physical interaction is now set. The next step is extracting this sense model act loop from a fixed room and placing it into a mobile chassis. As we move toward the next tier, this stabilized perception model begins to inform the capstone of AI engineering, true embodied intelligence.